Yeah, thanks, Ron. Thanks for that introduction. And again, like hopefully by as part of this talk, I should be able to cover or at least shed some more light that DevOps is not just a buzzword, but it is like something that is very important to the organizations as they grow and scale in the industry. So before we get into the discussion, my name is Amardeep Chadda. I go by Amar. I'm an enterprise solutions architect at AWS. I have been at AWS for over 4 years now. As Ron said, I'm based out of Twin Cities. So pretty much I kind of worked with various big and small organizations around the Twin Cities, Iowa, Nebraska, and so on and so forth. So as far as my technical chops, I like to focus more on IoT and also like in AI and ML as and when time permits. But today I'm going to specifically focus on DevOps and then we'll see what DevOps is. Oops. And we'll see like what DevOps is, what we mean by CICD. Essentially, CICD in this case stands for continuous integration and continuous delivery of your applications. And then we'll focus on one of our core AWS services or native AWS services called as AWS CodeStar. And we'll see how customers like you can leverage CodeStar to build their application and ship their code as soon as they can. Okay, so just a little bit primer slides before we get into the DevOps. Basically, the focus over here is to kind of broaden the scope a little bit, try to see like how industry has changed over the years. So typically at AWS, we start with like, hey, what is a modern application, right? So if you look at today's theme, the couple of discussions that have happened before me, like from Kunal and Ethan, pretty much both of them kind of focused upon modern applications, right? So even at AWS, we have a page that is kind of dedicated to modern apps. So like coming from the traditional kind of either waterfall development mode or three-tiered application architecture, organizations are evolving more towards serverless technologies. There is kind of more prevalent usage of containers and microservices. In terms of your customer base, you have to kind of either support web, mobile, or both. There are IoT applications, there are AI ML use cases, and so on and so forth. So basically, the approaches to developing all these applications are changing, and this slide lists out some of the key themes or key tenets or approaches that you would look at building in modern applications. So one of the key tenet over here is to basically kind of focus on CI/CD heavily, because as part of your modern application, since you have different components which are working together, you have to kind of make sure that your application teams are essentially would be spread out. Each application team is focused on delivering a certain component. How do you bring all of them together? And that's where CI/CD or continuous integration and continuous delivery comes into picture. And the reason why like modern applications are becoming so popular is because they kind of allow the businesses to innovate faster, right? And they're reducing risk, because security is very much very important these days. And given the recent impact that organizations or enterprises had with COVID-19, there is kind of more focused on being very agile and deliver value or change your business strategy pretty much overnight. And that's where the whole concept of DevOps comes into picture. Okay, so this is kind of a reference slide. So this is just if you think of them as swim lanes, as part of your SDLC, software development lifecycle. Every software has source, so it has a source repo or repository. Then you will be kind of compiling the DLLs or binaries from that build. You will be testing, and finally, the result, like once testing is good, it's deployed to the production. The focus, and this is kind of the SDLC pipeline that I'm going to refer during this slide, but essentially in terms of when we say CI or continuous integration is essentially the first three steps, right? It starts from your application or development team checking in source code. Once that source code is checked in, it gets compiled automatically. You run tests, and then you provide feedback to your application team based upon how your tests execute. And the second thing, like continuous deployment, essentially covers all of these four components, right? So as soon as as soon as a new change is checked into your source code, it should be automatically pulled, compiled, testing should be done, and it should be deployed to production as soon as everything looks good as part of your testing timeline. So it is essentially reducing the lead time. So lead time is whenever a business user says like, hey, this is a feature or capability we want to kind of deliver to our end users, and when that feature or capability is delivered to the end user. So continuous delivery essentially is meant to shorten that overall lead time. And this is kind of a reference slide which I wanted to kind of share with you. This just focus the importance of CI/CD as part of the DevOps culture itself, right? Because DevOps is a culture, and CI/CD or continuous integration and continuous deployment is one of the means to enhance and support or bring high responsiveness to that DevOps culture. So as per the latest like 2019 DORA State of DevOps report, essentially DORA stands for DevOps Research and Assessment Report. So as part of this report, more than 31,000 professionals across various industry types like large, medium, and small were interviewed, and their practices and their thought process towards application development and deployment were captured. And essentially, as part of this report, some of the key salient features that they have highlighted or tried to highlight is around like deployment frequency and lead time, failure rate, and so on. So what the analysts for the DORA report did is they essentially categorized these enterprises or 31 responses from 31,000 professionals into 4 tiers, depending upon their DevOps performance. So these tiers were like elite, then high, medium, and low. So in terms of deployment frequency between the elite and the low, we'll see like the low were doing their deployments from weekly or monthly basis, but the elite performances were like the elite performers were actually pushing out code pretty much hourly or on daily basis. And like just to quote something really close to home, like even on Amazon.com, we kind of do millions of deployments in a year. So there is like pretty much one deployment happening somewhere related to some functionality related to Amazon.com. So that's how fast we at Amazon are deploying. And in terms of kind of change in the lead time. So again, lead time is when business says like, hey, this feature needs to be available, and when it's available to the end users. In elite performers, it is like that feature is available between 1 to 7 days, which is really remarkable. So you can think about the flexibility or the agility that lead performance have in terms of the turnaround. And one thing that is really interesting is the failure rate. So failure rate is essentially the either amount of finding a bug as part of your deployment or your deployment completely failing. So you'll see like in the low performers, it is between 46 to 60%, but in elite performers, so people who are actually doing the deployments on hourly and daily basis, it is only 0 to 15%, which is really counterintuitive because normally you would expect like, hey, if you're doing more deployments, there would be more failures. But this is completely opposite to the norm, because the thing is that by building the automations via CI/CD, by building robust testing infrastructure in place, the elite performers are actually able to cut down their failure rate significantly as compared to people who are kind of doing their deployments which span like 1 to 6 months. Okay, so those are like, and that's kind of one of the critical factor or reason why a lot of organizations are moving towards DevOps culture and using CI/CD as one of the mechanism to make their processes robust. Now, changing our focus a little bit to what we have as components of CI/CD. right? So let's first look at what are continuous integration goals. So as part of continuous integration, basically you're looking at an automated mechanism, wherein you have a code repository. As soon as your developers check in the code repository, it's built and tested, and the feedback is provided back to your application developers. If everything looks good, then those assets or artifacts are ready for your deployment. So to meet these goals, when it comes to AWS, we have a native service within AWS called as Code Pipeline. So Code Pipeline is essentially an orchestration service via which you can integrate or orchestrate these different components in terms of what is your source repository, what are your build pipelines, what are your testing, and what are your deployment tools. You can bring all of these together, and you can orchestrate all of these components or pipelines as part of one big code pipeline. So another advantage to Code Pipeline is like it is a fully managed service. It integrates very well within AWS ecosystem, but it also has support for third-party tools as well. So like if you want to kind of bring in orchestration engines or other orchestration engines like Jenkins, or testing tools like Go Scripts or Blade Runner or Storm, something like that, you can kind of incorporate those external tools as well. So currently, like Code Pipeline supports either our Code Commit, which is essentially another AWS native service, which is a private Git repo, or GitHub, or if you have your code repositories that support webhooks, then you can easily integrate those repositories with Code Pipeline. So once you kind of create that orchestration, that would be kind of the high level movement of components within it. The second step is like once the code is checked in, you need to kind of compile the code and test the code. That's where there is another native service from AWS called as Code Build. So what Code Build essentially does is it can kind of create Docker containers based upon the platform of your choice. So we have native Docker containers as part of Code Build that kind of support either compiling like .NET, Java, Python, Node.js, and so on and so forth. So you can kind of easily spin up your infrastructure via Code Build. And since it's kind of fully managed, you don't have to kind of worry about how that infrastructure is spinned up. And you only pay by the minute, so that minute is how much time Code Build takes to compile your artifacts. And once those artifacts are compiled, you can actually execute test runs on it as well. So for any platform that is not natively supported inside Code Build, you can actually create your own custom Docker containers and port them into Code Build as well. Okay, so just to recap, as part of our previous slides, we saw continuous integration. So continuous integration is from source, build, test. So as part of the continuous integration from AWS native services perspective, we had Code Pipeline, which is an orchestration service, and we saw Code Build that can help compile your artifacts and test the artifacts or the compiled artifacts. So now moving to continuous deployment, right? So continuous deployment, as I said, spans across this complete SDLC pipeline. So some of the goals from continuous deployment are essentially not just getting the code ready for deployment, because one of the goals from continuous integration is getting the code ready for deployment, but continuous deployment is actually going that step further and deploying that code into your production. So that is kind of the key goal of continuous deployment, that your end-to-end pipeline should be tested, your testing framework should be robust enough, and once everything looks good, just go ahead and push out that code in production so that it is available for your end users or customers to start working with. So in terms of continuous deployment, we have another AWS native service called as Code Deploy. So again, this is a fully managed service. So again, you don't have to kind of spin up any infrastructure, but with Code deploy, essentially you can deploy not just to virtual machines like EC2 instances, but also to serverless services like Lambda. And also you can kind of leverage code build in hybrid architectures, wherein you can manage or deploy your not just your EC2 instances on AWS, but also your on-prem servers. So code deploy in itself kind of comes in with a lot of rich features, like it has various rules via which you can kind of do deployments. So it support rules like doing rolling deployments all at once, blue, green, A/B testing, and so on and so forth. So it has a lot of rich functionality built in. And also, like, it has automatic rollbacks as part of the feature set, so that in case your deployments do fail, you can roll back to the previous version. Okay, so quickly we saw like there are multiple tools, right, and tool sets which are available from AWS. So code pipeline is kind of the overarching orchestration. Code build is essentially for compiling your code and testing. Code deploy is pushing it out either to EC2 instances or serverless services. So there are like few tools over here, and each of these tools you can either use them together, or you can essentially leverage them individually as well. But there is kind of a lot of maintenance and operations involved, right? So you have to kind of provision these tools individually. You have to kind of give access to your application teams to these tools. You have to manage that access and so on and so forth. So it kind of does get a little bit cumbersome, right? Because if you have more tools, then there is more app operations and management overhead. So that's where, to simplify this whole CI/CD pipeline for our customers, to focus on shipping the code faster to their end customers, AWS introduced CodeStar. So CodeStar is a service that essentially takes care of your complete SDLC pipeline. So with CodeStar, you can get started very quickly. You can kind of develop, build, and deploy your applications on AWS in a matter of minutes. Right, so it kind of simplifies your management and maintenance operations with your team. So it has kind of built-in feature set for giving access to your teams in terms of contributor, admin, read-only, and so on. It provides various project templates, right? So it supports various platforms that you can get started easily. And we'll see some of that. Like, I do plan to do a quick demos, and as part of that demo, we'll see like how that console looks like and how you can kind of get started building your application quickly with CodeStar. But some of the notable features over here are like CodeStar is free, right? So we don't charge anything more. You are only charged for the underlying resources, like either if you leverage code pipeline, code build, code commit, or code deploy. You might get charged for those services. CodeStar is integrated with our native cloud IDE, which is Cloud9, but we also have integration with other IDEs like Visual Studio, Eclipse, and so on. And obviously, it kind of works very well within AWS ecosystem across various services. Some of these services are listed over here, like EC2, Lambda, Code Commit, Elastic Beanstalk, and so on and so forth. Okay, so also we have integration with third-party extensions, what we call as GitHub and Atlassian JIRA. So this is for issue management, right? And code repository as well. So like you can host your code repo in GitHub, that is integrated. If you want to do your issue management in GitHub or with JIRA, that is integrated as well. Okay, so I'm going to quickly move to my browser, but as part of the demo, essentially, I'm going to kind of do a quick run of what CodeStar console looks like. We'll quickly spin up a sample application, and then if time permits, I'll kind of make a quick change to the application code with Cloud9 and deploy it to see like how that might work.
Amar, it's Ron Gerber. Just one question that came up from Saeed and Eric was, Well, how do you go about actually implementing DevOps, not so much from a technology standpoint, but how do you tie together the developers, the programmers, the IT operations line of business? Maybe if you could weave some of your own personal experience into that. My own sense from having run so many Angel Bee events and talking to so many people is that you just need to get together, be it virtually or hopefully in the near future in person, between these three groups, get together. Everyone's aware of how important technology is, have people understand what the end users need, what the line of business needs, understand what the programmers are capable of. The IT operations people need to then determine how often applications need to be maintained. How do they need to be displayed or work on different devices, different networks? It's simply meeting and talking more is the best way to implement the changes to go, as Eric was alluding to, from 12 to 18 months to 1 to 2 months. Maybe if you could comment a little more on that over the next 20 minutes during your session on your real life experience.
Sure. So to summarize that quickly, obviously whatever Ron, you said are very valid tasks or options that customers or enterprises do in terms of implementing DevOps. But DevOps essentially is more of a cultural shift as part of the enterprises as compared to their existing cultures. Like a lot of the enterprises still are working in the waterfall model, wherein your BAs, like business analysts, will work directly with the business users to gather the requirements. Then BAs essentially hand over the requirements to your application team. Your application team then builds or writes that code, hands it over to your testing team. Testing team will then kind of evaluate or test that code and hand it over to your infrastructure team, who will kind of go ahead, either do the release management, deploy the infrastructure, and so on and so forth. So again, like in a lot of cases, there are silos, right? There is no interaction across these teams, right? From your business users to your infrastructure management and operations team. So what DevOps is trying to do is, like as Ron said, it's essentially trying to bring all of these teams together. And some of the mechanisms, like how enterprises can bring these teams together, is first and foremost is kind of moving away from waterfall to more of an agile approach, right? So one of the things that agile approach brings is it kind of breaks down your processes into consumable bites, which are called as essentially sprints. And as part of that sprints, you can pull in resources across your either business users, application teams, infrastructure teams, testers, and so on. So you're kind of creating these small teams that work together in achieving a specific goal that is defined as part of the sprint. So when it kind of comes to Amazon, like at Amazon, we call them as 2 pizza teams. So these teams are like small enough that they could be fed by 2 pizzas. Right, so we are not kind of making very like hundreds of developers team. They are like very small, and they are very focused on either delivering a specific capability in terms of a service or kind of achieving a specific task. So it kind of creates a very cohesive team who is responsible from end to end of your SDLC, right? So from software delivery lifecycle, we'll see these teams are responsible for doing that. So like agile frameworks especially kind of start or kick off that kind of mentality. And second thing, which is very key to DevOps, is having automation built in as part of your CI/CD processes. Right. So if you are kind of looking for transformation as part of your organization, essentially you need to kind of start focusing on 2 things. One is changing to agile culture, and then thinking about more of automation processes as part of your application pipelines. Okay, I think hopefully that was helpful.
Yes, I would continue. Appreciate that, Amar.
Okay, so I'm sharing my web browser. Just let me know like if you are able to see the web browser. Are you guys able to see it?
Yes, the AWS Management Console.
Okay. Yes. Okay, so here is the link to which is kind of in my slide as well, like, hey, how to build modern application. And this is like something you have heard in the previous slide as well. So I kind of just wanted to quickly share that. But as part of the demo, essentially, I've logged into my AWS Management Console. So if you're using the AWS Management Console for the first time, this is the look that you get. We have like recently visited services over here and a list of all our services over here. And this list is continuously growing. At least for today, we are going to kind of work with CodeStar. So you can come in and just search for CodeStar, which should take you to our CodeStar dashboard or console. So right now, today, like right now, I'm in Northern Virginia, but you will get a complete list of all the regions where CodeStar is supported. So if you are using the AWS CodeStar for the first time, you won't see this page. Essentially, you will see a getting started page where you might have a blue button which says get started. Just click on that and you will come to this page. So if you want to create a new project, just go ahead, click on that create new project, which brings you to CodeStar project template. So you will see we have actually multiple platforms and multiple templates already built in to easily get you started. So you can either browse through all of these templates, or you can kind of just pick and choose what you want to do from the left hand side options. So today I'm planning to quickly show you how to build a web application. So I'm going to go ahead, select that web application. My choice of programming language is C#. You'll see like we have multiple other choices over here as well. So I'm just going to go ahead, pick and choose a web application with C#, and I'm going to kind of give it a name. Let's give it Angel Beat Virtual Seminar. And you'll see like today we kind of have support for 2 repositories out of the box. It's one is code commit, other is GitHub. So code commit is our native code repo, which essentially you can think about it as a private Git repo. Okay, you can once you select that, you can go ahead, click next. So over here again, this is the reference to the CICD pipeline, and you'll see like how our services fit across these swim lanes. So like code commit is for source, code build spans across build and test. For deployment, we have code deploy, and then eventually monitoring, we have CloudWatch. And over here, it shows you the EC2 instance on which we are going to kind of spin up a sample website. So if you want to go ahead, change it, there are different options available over here. I'm going to keep the defaults and then just move on. I'm just going to choose one key pair for our EC2 instance. Over here, it shows the different IDE integrations, right? So Cloud9 is our native cloud-based IDE. But in addition to that, you can actually integrate either with Eclipse or Visual Studio. If you click on either of these, you will see like there are robust instructions which are provided to you how to integrate with your specific IDE. But at least for this demo, I'm going to choose Cloud9. So over here, you'll see like the processor already started spinning and creating a repository for me. So go ahead, click next. This is essentially an EC2 instance that is getting spinned up for my Cloud9 environments. And there are like some additional information over here, which I'll kind of keep it to you guys to take a look at it. But kind of go ahead and I'll click next. So now it has started spinning up my EC2 instance. So in interest of time, I'm just going to move to another region where I already have this spinned up. Typically, it takes roughly around like 5 minutes to spin up your CodeStar project. But once your CodeStar project is spinned up, this is how it will look like. Behind the scene, what it does is it actually spins up an IDE for you. It will spin up a code repo, your code build pipeline, code build project, your code deploy project, your code pipeline project, and themes, extensions, and some project settings. So let's look at a few of these components over here. So like in terms of teams, whoever creates the project, in my case, I created the project, so I'm the owner, but you can kind of add additional members. So these additional members could be either your IAM users, or you can federate these additional users from your Active Directory or a SAML 2.0 compliant IDP. And then in terms of extensions, we support either GitHub Issues or JIRA, and these extensions are readily available in the console itself. So you'll see the issues is right here. So just a quick overview of the console. So you can also kind of build your team wiki. So if there are any specific instructions that you need to give to your team members, they are available right there. In terms of commit history, it is available right here. Your CloudWatch monitoring activity is right here, and JIRA activity or issues are right here. And then on the right hand side, you'll see your deployment, and this is your application endpoint. So again, like as part of our sample application, we are kind of just spinning up a very vanilla kind of based .NET application that just has one web page which says congratulations. Okay. In terms of your IDE, currently this is kind of integrated with Cloud9. So let me kind of just go and spin up Cloud9 quickly. So this will take less than like a minute to spin up your IDE environment, because one of the good features with Cloud9 is whenever you are not working on your IDE, it automatically stops or pauses itself. So essentially, you're not paying for the compute resources, but it does keep all your source code as part of EBS volumes, which are attached to these instances. So currently what it's doing is essentially it's kind of trying to spin up a new compute instance, and you'll see like it's kind of pretty quick. It's already up and running and available for me to start working. So this is the sample code that has been kind of deployed from your code repo and is available to start manipulation by your development teams over here. So to quickly look at your code repo, so this is the code commit repo that has been spinned up for you. So this is pretty much a Git compliant repository. So you can work with it in similar way, like in terms of your Git commands, they all work with this. And also like we have a README available if you want to kind of take this sample report and start extending on top of this. And then in terms of build, it kind of creates a build project with all the configuration for you. So this is essentially the build project that will compile any changes and deploy that. In terms of deploy, we again kind of create a code deploy project for you with all the configurations already done. And then pipeline is kind of interesting that it kind of creates the full code pipeline with bringing your code repo, like code commit, your code build, and your code deployment together. So behind the scenes, essentially, it's kind of leveraging AWS CloudFormation, which is infrastructure as a code service, to actually go ahead and deploy your code onto an EC2 instance. Okay, so if your application teams wants to kind of manipulate your application, they can kind of quickly go to Cloud9. Since like this is a pretty vanilla application, I'm kind of just going to go in over here and make a change. So this is the text that shows up as you just created an ASP.NET Core application, and I'm going to change it to welcome Angel B attendees. So since we have that test suite available over here as well, I'm just going to go ahead and update it over here so that we don't see any code build failures. We'll kind of go ahead and save these files. Okay, so once these are saved, you can essentially go ahead and use your Git commands, right? So I'm doing a quick Git status. So it shows that, okay, I've changed 2 files now. So I'll do git add everything. Oops. Then I'll kind of go ahead and commit my changes. Okay, then I'll go ahead and push it. So once these changes are pushed in the code repository, the code pipeline will essentially pick up those changes and it will start building your pipeline. So over here, you'll see that the change has been made. So code pipeline automatically detected that, hey, a new change has came in. So it's kind of looking for that change. Once that change has been identified, it will kick off the build project, and then the build will compile it, and finally it will kind of go ahead and deploy it to your site. So again, like this process itself takes roughly around 5 minutes. In interest of time, I'm quickly going to change back to my previous region, and I'll quickly show you how that looks like. So I have this CodeStar test, which already has those changes made. So once those changes are deployed, essentially it should look something like this. Angel Beats webinar attendees. So that's like how easy with code suite of like DevOps native services like code pipeline, code commit, code deploy, code build, like Cloud9, your developers can easily kind of create your applications. In this case, it was kind of a sample app and kind of just start pushing it out to your end users. Okay, any questions on this?
No, I think that was very good, Amar. I would ask you to start summarizing, or I guess looks like you're almost finished right now.
Right, yeah. So again, in summary, we saw 3 to 4 native DevOps tools from AWS, and we saw like how CodeStar can bring all of them together and kind of just allow you to focus on shipping your code instead of kind of worrying about, hey, how do I kind of create my infrastructure? How do I manage access? How do I give access to these individual services to my various application teams and so on and so forth? So that's where the true power of CodeStar lies, that kind of get you started very quickly and meet your business objectives.